Okay, let's go through the part B of this PJC question. So the diagram shows a sketch of the part of the curve y equal to cosine bracket x square bracket. So we are asked to find the exact volume. Also, exact volume means you cannot use the GC already, of the solid generated, right, when the region bounded by this curve, the axis, meaning the y and x-axis, and the line x is equal to square root pi over 2, right? It's actually rotated 2 pi about the y-axis. So meaning that this part, right? So if I shade the region, so it should be like that. So this is the first region. Then the second region is around here. So I'm going to rotate about the y-axis for 360 degree. Okay, so definitely you can see for the blue region, right, it's actually a cylinder. Yeah, then for the purple region will be just arbitrary solid revolve lah. Okay, so first thing first, let's determine what is the y-intercept here. So for example, the y-intercept here will be about 1, because we simply just sub in y equal to cosine 0 square, which is just 1. Okay, then for this part, right, there's this part here. So this part will be about y is equal to, because you can see that this x coordinate is square root pi over 2. So you just put y is equal to cosine square root pi over 2 square, right? The whole thing square is just pi over 4. So you do the calculation, cosine 45 degree is about 1 over root 2. So this part is 1 over root 2. So this 1 over root 2. Okay, so with this, let's do the calculation for the cylinder first. So for cylinder, we don't need to do the integration. We simply just use the pi r square height. So for the volume of the cylinder, so this part, right, we simply just use pi r square, because our r will be your square root pi over 2. So square root pi over 2 square, then you multiply by height, because the height is from here all the way to here, which is 1 over root 2. So this will give you pi, and here will be pi over 4 multiplied by 1 over root 2. So this will give you about pi square over 4 root 2. Alright, so that will be the volume of the cylinder if you actually revolve around the y-axis. Okay, then there's one more region, right, which I highlight in yellow. So this is the region that we are interested in as well. So since it's rotated 2 pi radian about the y-axis, right, so there's one formula. So the formula will be given to be pi integral of x square dy. So we are going to integrate from 1 over root 2 to 1. So from here is 1 at the upper limit, 1 over root 2 as the lower limit. Okay, then with this, let's go back to the equation. So we are given y equal to cosine x square. Because I'm interested in the x square, so I'm going to inverse it. Y equal to cosine x square, I'm going to inverse become, because I'm going to get the x square as a subject. So y is equal to cosine x square. So you just go do the inverse. So x square, right, is equivalent to cosine inverse y. Okay, then just need to do the sub inside. So cosine integral of cosine inverse y dy. So this will give you 1 over root 2. Then here will be 1. So by one look, this one is your integration by parts, because we cannot really integrate cosine inverse y directly. So you must do the by parts. So this is 1. So by parts, right, of course you must let something be u and something be v. So the u, I will let it be cosine inverse y. The v, right, will be your 1. Okay, so this will give you pi. Okay, then we do the keep integrating, right? Keep integrating minus integral, differentiate, integrate. So keep is the u, which is cosine inverse y. Then the integrate 1, right, will be y minus integral differentiate cosine inverse y. So this one, when you do the differentiation of cosine inverse y, right, just go back to your MF27. So this will give you minus 1 over square root 1 minus y square. Of course, this part will be your integral of 1 is just y. So this part will be here. So with this, right, of course you can take out the minus. So minus is plus. So this one is plus. Later we dy. So later we will just do the definite integral, but let's solve this first. So by looking at just this part, so this one is another formula that you can use, right? Because this is something like your integral of f(x), then after that bracket, so f prime x, then fx bracket to the power of n. Yeah, so with this you simply just apply this formula. So this part will be just your integral of y, then the square root you bring up become 1 minus y square to the power of negative half dy. So you can see that actually for this, right, is your fx to the power of n. Then for this will be your y. So of course I need to do a bit of manipulation first in order to get the f prime x, fx to the power of n. So you can see that you differentiate 1 minus y square, you will get minus 2y. So means I must put a minus 2 right here. So minus 2. Then of course outside you must put negative half. Because you cannot change the thing. So I'm just multiplying by y, right? So this will give you, so this part, right, will just give you minus half. Then this part will just integrate directly, right? So this will become 1 minus y to the power of 2 bracket, then you plus 1 is half. Then you divide by the same power, half. So this will just do the cancellation, like this part and this part can cancel away already. So this will give you pi cosine inverse y, then the y just put in front, y, then minus 1 minus y to the power of 2 bracket to the power of half, then put a square bracket. So this is 1, this is about 1 over root 2. So it's time to do the definite integral. So you sub in the upper limit first. Pi, okay, so if you sub in 1, y to be 1, so it's 1, then cosine inverse 1, right? So this is 1, I think it's 0 if I'm not wrong. Yeah, it's 0. So minus, so you sub in 1 here, so maybe I put a bracket. 1 minus 1 square, right? Just your 0 as well. So the whole thing is 0, minus of bracket, so I put 1 over root 2, so this 1 over root 2, and then cosine inverse 1 over root 2, cosine inverse 1 root 2, right? So this will give you pi, 45 degrees pi over 4, so this will be pi over 4. And you put a minus, and of course again is 1 minus y squared, so it's 1 minus half, and the whole thing to the power of half, and put a square bracket. Okay, so with this, so this will become pi, and the whole thing right here will become 0. So it's just 0 here. So 0 minus, okay, let's do the simplification of this thing. So this thing will be just pi over, so it's just, I put a minus sign first, pi over 4 root 2, put a bracket, and minus of half. So it's half here, then you to the power of half again. So means it's half the whole thing square root. So it's as good as saying 1 over root 2. So it's minus 1 over root 2, put a bracket, square bracket. So this will become pi bracket, and then I just do a bit more simplification. 1 over root 2 minus pi over 4 root 2, and put a square bracket. Okay, then you simply just multiply the pi inside. So this will give you pi over root 2 minus pi square over 4 root 2. So this will be the volume that is being revolved, right, for this part. So you can see this part, right? So this part is the volume that is being revolved for about the y-axis for 360 degrees. But of course, not to forget the volume of cylinder is right here. Pi square over 4 root 2. So we must add up. So pi square over 4 root 2, right? So we can see that the total volume will be pi over square root 2 minus pi square over 4 root 2 plus pi square over 4 root 2. So this will result in the total volume to be pi over root 2. So that is how we do this question. Yep, so it's pi over root 2.